We're starting today chapter 14, and with the law of cosines. You're going to be given the law of cosines on your Regents reference sheet, and it looks like this. A squared equals B squared plus C squared minus 2BC cosine of A. So first let's look at what all these letters mean. Lowercase a, b, and c, which appear in all those places, are the sides of a triangle. So side A is across from angle A. Side B is across from angle B.
Alice Mucci,
And
Alice
side
Lana,
C
Terrell Mack, please report to the main office.
is across from angle
Riley
C.
Moyer, Brandon Daniels, Leah Miles, Connor Main, Jessica Mejia.
All right, I think they're done. Side C is across from angle C. The angles are in capital letters, so this cosine of A right here, that A is angle A. So it's given to you in that form, but you should be aware that you might need to find side B. If you need to find side B or find side C, then we're going to adapt the law of cosines to suit this. So if I'm looking for side B, I'm going to have B squared equals the other two sides, A squared plus C squared, minus 2 times, and those match these, so 2 times AC, and the cosine of the angle across from side B, angle B. If I'm looking to find side C, then I will have C squared equals the other two sides, minus 2 times those, AB, and the cosine of angle C. As a little check, if you're ever worried that you have it set up right, you can see that this side out here matches across from the angle out here. So this pink is a little dark. This B squared across from angle B. This side C across from angle C. So the angles at the ends match. Let's go down and do this first example, because it's related to this topic. It says in triangle MAR, so I'm just going to sketch a quick triangle, MAR. I always draw pictures here. And let's label the sides across from each angle. So across from angle M would be side M, lowercase. Across from angle A, side A. Across from angle R, side R. So they're asking us to express m squared, wonderful, m squared, in terms of all the others. So they just want you to write a law of cosines, but this time you're using m, a, and r. So m squared equals, you might want to pause the video and see if you can do it, the other two sides, a squared plus r squared, minus 2 times those, times the cosine of angle M. You said angle M, you are right. Remember, I use the same color. This side across from this angle. Okay. So as a hint, and all the ones we're going to do today use the law of cosines, but as a hint, you're going to use the law of cosines when you're given information in the order of side, angle, side. Then you'll use the law of cosines to find the third side. And you're going to use the law of cosines if you're given side, side, side. And we'll see some of those at the end of the notes. There you can use it to find any angle. So it's handy. Let's go ahead and look at some problems, some real problems. We're going to draw a picture each time. We're going to set up the law of cosines based on the letters and what we're looking for. And we are going to solve the problem. You'll need your calculator as well. So this first example here. In triangle DEF, Side E is 8, side F is 3, and the cosine of angle D is 3/4. So I'm not given the D angle, I'm given the cosine of D. Find D. So let's set up our law of cosines. Can you do it? D squared equals the other two sides squared minus 2 times those times the cosine of the angle D. Let's fill in what we know. We know we're looking for D, so we're going to leave that. E is 8, F is 3 squared minus 2 times 8 times 3, that's not a decimal, times the cosine of D. Now remember, they gave me this whole thing, so I'm just going to put 3/4 here. And now it's just arithmetic. You can show some work. Let's put in to your calculators 2 times 8 times 3, 2 times 8 times 3 times 3/4, or 0.75. And we get that is 36. So D squared is 64 plus 9 minus 36. It's 37. And then we square root. And yes, we should put a plus and minus, but we do know that it's a length, so it's positive. So we don't really have to do the plus and minus. Square root of, I don't know why I wrote 39, square root of 37, and that is the answer. If we needed it in decimals, that's approximately 6.08. Your calculator would show all of that. Okay, first problem done. Let's try the next one. At any time, if you want to try it on your own, pause the video and check your work. Find the exact value of the third side of triangle PQR. Okay, PQR. Given side P, side P is over here, is square root of 3. And side Q is 5. Side Q would be over here, right? And the measure of angle R is 30 degrees. So notice, just as a hint, again, the information that's been provided is a side, and then the angle that makes with this other side. Side, angle, side. So that's a nice hint that we're going to use law of cosines. So it says find the third side, so we are now going to look for this third side R. And that's what our equation starts with. R squared equals P squared plus Q squared minus 2PQ cosine of angle R. Go back and substitute in what we know. We know we have the square root of 3 for side P. We're going to square it. And 5 for side Q. We're going to square it. Minus 2 times P times Q times the cosine of 30 degrees. And as a side, let's figure out what is the cosine of 30 degrees. It's a chart value, and it's equal to the square root of 3 over 2. So we'll be doing that in the next step. Square root of 3 squared is 3 plus 25, and let's see, 2 radical 3 times 5 times cos of 30. 2 radical 3 times 5 times radical 3 over 2. So my 2's will cancel, and radical 3 times radical 3 is 3, and times 5, that gives me 15. It's minus 15 here. So let's see, R squared equals 3 plus 25 take away 15 is 13. And they wanted the exact value, remember, so we're going to leave it in radical form, square root of 13. Okay. Hopefully you're doing all right. Let's keep rolling here. Pause it at any time. Write down any questions you have. Let's do our third law of cosines example. Find the measure of side A to the nearest tenth, given side B is 10.6, side C is 4.3, and the measure of angle A is 158 degrees. So, because angle A is obtuse, I'm going to draw my triangle so that I have an obtuse angle at A. Let's put that 158 right in there. So angle A is labeled. Side C is 4.3 and side B is 10.6. And we're going to find side A. Pause it, see if you can set up the law of cosines for this one. It's A squared equals B squared plus C squared minus 2BC cos of A. Let's put in our values that we know. We're going to have 10.6 squared and 4.3 squared minus 2 times 10.6 times 4.3 times the cosine of 158. Now, one thing that's important to realize here, the cosine of 158 is actually a quadrant 2 angle, and it's cosine, so this is going to be negative. Because this is going to be negative, the end result will be that this subtraction will turn out to be addition. So if you're showing your work step by step, be aware of that. It's important to realize why it becomes addition. But this time I'm going to give you another hint as well to successfully doing these. This entire side of the computation can be put in your calculator as is. So let's give that a try. On my calculator, 10.6 squared plus 4.3 squared minus, that's what it says, 2 times 10.6 times 4.3 times cosine of 158. Do a quick check. Make sure you're in degree mode. I have to change mine. And hit enter. So we can put that whole line of work right in your calculator. And say that we have A squared equals 215.3720802 and square root that answer, and we've got side A, and we want to look at the nearest tenth. I had underlined it, and 14.7 it is. Terrific. Jot down questions if you have them. Let's keep going. So whoops, I went 2 pages. The next page has a problem at the top that says, if 2 forces of 100 pounds, and this should just be 80, 2 forces of 100 pounds and 80 pounds act on an object at an angle of 50 degrees to each other, what is the magnitude of the resultant force to the nearest hundredth of a pound? So this is a special type of question. We're going to draw forces questions like in the form of a parallelogram. So you can see I have the 100-degree force along the bottom and the 80-degree force coming up with that 50-degree angle between them. Okay? 50 degrees between them. So some of the rules for, or the properties of parallelograms that we're going to need you to remember is that opposite sides are congruent. So I'm going to label this 80 over here. I could label this 100 up here. And that consecutive angles, this angle and this angle, or in our case, are 50 and this angle. Consecutive angles of a parallelogram are supplementary. So we're going to label this 130. So it helps to have some of this labeled because they want us to find what's known as the resultant force. When forces are applied in physics, you would learn this. When forces are applied on an object in directions like this, the object will move diagonally. This is what's known as the resultant. So we'll call it X. It's what we're looking for. And once your picture is nicely drawn, you can focus now on this triangle. Ignore everything else in the problem. Even ignore the 50, because the 50 is not going to help us. We're looking for X. X is across from the 130. It's a side problem, so we are all set to use law of cosines. X squared will equal the other two sides squared. Minus 2 times those sides times the cosine of the angle between those sides, 130. Let's go ahead and put this whole line in our calculators. 80 squared plus 100 squared minus 2 times 80 times 100 times cos of 130, enter. And that gives us 26,000 plus. Decimal. And square root it. And we have for our resultant 163.3542217, nearest hundredth, 163.35, and we're good. Okay, so those were all the side angle, side types of questions. Now we want to do some where we are given all three sides. So let's start off by labeling our triangle. And we're going to find the measure of each angle. We might do a couple of these together, and then I'll leave one for you. Each angle. So, side P is 6. That's over here. Side Q is 12. And side R is 15. So we're going to start off with a P squared. So P squared would equal R squared plus Q squared minus 2RQ cosine of angle P. Remember this side across from that angle. Now we're going to actually go find the measure of angle P using these three sides. Let's fill in. 6 squared equals 15 squared plus 12 squared times 2 times 15 times 12. And we don't know the cosine of P. And be careful, because all of this is one term. You'll see what happens there. Here we have 36 equals 225 plus 144 minus, we can multiply these together, but remember they're glued to cosine of P. So 2 times 15 times 12 is 360. Cos P, so that's its polishing it up a little bit, 36 equals This is 225 plus 144, 369, minus this term. Keep this term by itself, kind of off to the side. We're going to subtract 369 over. And that gives us negative 333 equals, and our term we're leaving over here, negative 360 cos P. So I can get cos P alone by dividing by 360, negative 360. And so I have, let's see, cosine of P equals negative 333 divided by negative 360. Turns out to be a pretty nice decimal, actually, 0.925. That's the cosine of P. Remember, our goal was to find angle P. So how are we going to find angle P? P alone, we will have to do cos inverse, boom, and cos inverse. Make sure you're in degree mode. And the cos inverse of 0.925 is about 22 degrees. So let's round. I think we can round for some of these. Let me do this again on my calculator and make sure we get second cos 0.925, and it was 22.33, if you want to make a note of that. And what I'm concerned about looking forward is you want to remember that all the angles of a triangle should add up to 180 degrees. Let's do the same thing, but with R. Let's go find angle R. So if I want to find angle R, I need to start my equation with R squared equals, and of course it'll be P squared plus Q squared minus 2PQ cos of angle R. Fill in our values. R is 15. P is 6. Q is 12. Just got to square those. 2 times 6 times 12. Cos of R. There's that big term at the end. We're not going to mess with it. 225 equals 36 plus 144. You might want to pause the video and see if you can finish this one up on your own, and then come back and see if you got it. 2 times 6 times 12 is 144 cos R. Remember, this is the guy. I'm kind of leaving it over here by itself. I don't want to mess with it. So we have 225 equals 36 and 144 is 180. Don't mess with that term. Bring the 180 over. So we're left with 225 take away 180 is 45 equals negative 144 cos of R. Let's divide by negative 144. And what do we have? Cosine of angle R is equal to, let's do it this way for consistency, the cosine of angle R is equal to 45 over negative 144. That's also a pretty nice looking decimal. Negative 0.3125. Don't lose that negative. And then do your second cos. It's negative. Remember that negative for a cosine means we're going to get a quadrant 2 angle. If you put the negative in your QRS, you'll get the actual quadrant 2 answer. So let's do cos inverse of negative 0.3125 on your calculator. And you should have that angle R is about 108 degrees. I'm going to do that as well. Second, cos negative 0.3125. And we have 108.21. That's how I got that 108. So I will leave Q for you to do there. Q squared. Set up that law of cosines and see if you can get the third angle realizing that angle P plus angle R plus angle Q should add up to 180 degrees. But I want you to do the work for angle Q to confirm that. Let's look at our last problem, and then we're done. A beam 16.5 feet long supports a roof with rafters each measuring 12.4 feet. What is the measure of the angle at which the rafters meet? That's nothing. So we're looking for this angle. It's across from this side. It's a side problem, so we're going to use the law of cosines. Last one. Since it's this angle we're looking for, we're going to start with this side. 16.5 squared equals the other side squared plus the third side squared minus 2 times each of those. And the cosine of the angle I'm looking for. Make sure that angle is across from this side, and you're set to go. I'll let you finish that, see if we can get that angle up there between the rafters, and I'll see you tomorrow.